Okay, so I'm Brian Savery. I am a developer at Pixar working on the Renderman software. And so basically I'm going to talk today for about 10 minutes of running Pixar's Renderman inside of Blender. Then we're going to do some demos. Then I'll do questions. So if you have any questions as we're going along, just drop them in the YouTube chat and we can get them in. And I'll jump into the YouTube chat later if you have any other questions that we don't get to. So throw the questions in there or anything like rendering related. Doesn't necessarily have to be about Renderman, and we'll get to that. Okay, so Pixar's Renderman is the renderer that Pixar developed way back in 1988. So it's been around for quite a bit. And it's kind of the granddaddy of all renderers. But in a way, it's actually one of the newest renderers because it was completely rewritten in 2015-ish. We came out with a new version of the renderer called RIS, which is a path tracing renderer, similar to Cycles. But you can see that our history with Renderman goes way back into 1988. So we're coming on 30 years here. And Renderman's been used in plenty of motion pictures. The Jungle Book just won an Academy Award for Best Visual Effects, and that was using the new RIS path tracer. Finding Dory, Rogue One, Ex Machina won the Academy Award last year. So basically, it's been a pretty well proven render over the years. So we're also giving this away for free for users. So there's a non-commercial version of Renderman. So if you want to try it out for Blender, you can just go to renderman.pixar.com and you get a free non-commercial version to use. What do I mean by non-commercial? It's free to use if you're not doing stuff like making Man in the High Castle effects that you're selling. If you're a home user, if you're an academic user, whatever reason that you want to try out Renderman, maybe you want to learn the workflows that artists and studios are using, or you want to use a different renderer. It's free for that. If you're a professional user, we would love to sell you a license of Renderman as well. And also we do donations for educational purposes. So if you're like a school, just contact rendermansales@pixar.com and we'll take care of you for licenses. And we have a lot, if you follow the link here, or if you just go to renderman.pixar.com, we have a lot of tutorials on installing and more info there. So the add-on itself is an open source project and something a little new for us at Pixar and the Renderman group. It is community driven, so we have this non-commercial version of Renderman and we want to get it out into the hands of users like you. And it's also driven by the community, so we're getting a lot of code contributions from a bunch of guys. They're all listed here. I want to give a shout out to them because they've been really helpful in this. And then usually I'll go and review the code changes that people submit for the add-on. And we're always looking for new developers. So if you're interested in learning development, it's all in Python. It's pretty easy. Or if you just want to get your foot in the door in the industry, is kind of a good resume builder as well. So just contact me if you have any questions about helping out with the add-on. So why would people use Renderman? Like I said, it's industry proven renderer and does really, really complex shots very well. It is, like Cycles, a path tracer. So they work with similar algorithms. And we're not trying to take anything away from Cycles. Cycles is a great renderer. But we have some different workflows and different shaders and some new tools like the denoiser that have been developed and worked on and used at Pixar Studios, and we're trying to get those into the hands of Blender users. So when it comes to reasons why you might want to use Renderman, there's some new stuff that are really cool to check out there. We'll get into that later. So the number one question we always get is Renderman faster than Cycles? Now, like I said, they're both path tracers, so you'd expect them to have similar amounts of time for rendering. But really the question I think people should be asking is not how fast does your render happen? And, David and the other guys can talk about this in their, when they were doing Man in the High Castle. The time it takes to render a shot isn't necessarily as important as, especially with the path tracer, how much time does it take to get a certain amount of noise? So what I did here was I tried to match the render times between Cycles and Renderman and sort of look at how much noise there is after a given amount of render time. So we have on the left here a Cycles render that took 2 minutes 40 seconds. In the middle, a Renderman render that took 2:44. And then on the right, there is a Renderman render in using the denoiser, but I lowered the number of samples. So then we're going to zoom in here. So basically, another way of looking at it is, let's say I want to I have 10 hours to render my scene. How much noise is my renderer going to have after that 10 hours? So let me go over here. We'll just full size this. All right, so here's the Cycles render. So if we zoom in, especially in these background or sort of like these sort of like diffuse, sort of in the shadow areas, we see we have a little bit of noise here in the shadows. And again, this was 240 on Cycles. Now we go to the Renderman render. There's ways of measuring noise. The lighting isn't exactly the same. I try to match it up quick and dirty here. We might have a little bit more noise in the Renderman render. But then if we go and look at the one that we use denoise on, we actually see for a similar amount of time rendering, we have almost no noise in the renderer. And the important thing is with denoising that we're not losing details, like for example, the edges of the pattern here, we're not blurring across those edges. And then stuff like, if we switch back and forth between the denoised one and the not denoised one, we're not losing specular highlights up here. All right, so that's basically what I want to get across when people ask, like, how fast is a render? I don't think that's always the right question to ask. You want to know how much noise do I get from a given amount of render time. Okay, so another strength of Renderman is that it can handle large amounts of complex geometry and huge complex scenes. You're used to seeing Pixar scenes like this this shot from the Piper short, which just won an Academy Award for Best Animated Short. So here we have this shot from Piper, and the ground plane, it looks like it might just be some texture to make it look like there are sand grains there. But no, we actually went in that short and modeled each grain of sand. Each one of those grains of sand has about 5,000 polys in it, which is kind of insane. You can multiply that out by the number of, oops, sorry, I went too far here. You can multiply that out by the number of grains of sand, and I think it's approaching some silly amount. But we're using instancing, so in a path tracer, it's pretty cheap to do that. But anyways, so the point is that we handle insane amounts of geometry. The other cool thing about Renderman is we can do these really sort of cool, complex lighting effects. Like, for example, here we have an emitter on this plane, and it's just one light in the scene, and then we're shining it through a Fresnel lens, and we get this complex, physically based light focusing on the wall here. And this is basically a caustic that is being used. We have a bidirectional path tracer as well as a unidirectional path tracer. Cycles, I'm pretty sure, is a forward path tracer, but we have a bidirectional path tracer, which means that you trace rays both from the light source and from the pixels that you're shading sort of meet up and find where the light rays sort of intersect. You're able to get these really cool caustics that resolve sharply with it. We can also handle insane amounts of lights. So this is a screenshot from the Coco trailer for our animated movie coming out in November. Coco, this shot has in the millions of light sources. I'm not sure the exact number, but it's in the millions. I think it's less than 10 million actually, but it's really, really hard, as the theory guys can talk about, to resolve a scene with this many lights in it. And we're pretty proud of the fact we're able to do that with Renderman. Okay, so another reason you might want to check out Renderman is that we have a lot of the features, because we've been around so long, we have a lot of the features that Cycles is kind of up and coming and putting in. So if you look at the feature list for 2017 that Cycles is working on, they just put in adaptive subdivision. On the right, we have a scene from Jerry's game, which I think was 1998. And that's when we added adaptive subdivision to Renderman. So we've had that for a while. The Disney BSDF is going in 2.79 version of Blender. You can check that out in Renderman. Shadow catchers, IES lights, light groups, and light linking. I'll go into those in my demo. And then the denoising, we talked about it a little before, but the denoiser is being worked on for Blender as well. And that is also available in Renderman. So all these features that are going into Cycles, you can kind of see where they came from with Renderman. Okay, so one of the really cool features I alluded to it before was in Renderman 21, we have this Pixar Surface BSDF, which is the main shader that was used in Finding Dory for almost everything. It's kind of a really cool Uber shader. It's similar to the Disney shader, but it lets you layer stuff. So with the Disney shader, you can't layer. But it lets you do stuff like diffuse as multiple specular lobes, subsurface scattering, thin translucency, and pretty much everything in Finding Dory was done with Pixar Surface, Martian Hair, and our volume shader. So here is Dory, and there should be a turntable. There we go. There's a turntable running. Everything you see on her was done using Pixar Surface and layers of Pixar Surface, and you can see the eyes, the glass of the eyes, and the translucent fins. Those were all done with Pixar Surface, and the plastic, and the chrome, and the diffuse balls. Everything here is Pixar Surface. So it kind of talks about like the flexibility of using that shader. And again, that's available in Renderman, and it's the same shader used in Finding Dory. So I'm going to go into a demo. I'm going to do a little bit about the shaders with Pixar Surface shader, and talk about light linking. And so this image on the right here is actually another experimental feature we have in Renderman, which is kind of cool. It is a volumetric caustic integrator. It's called UPVP. It's basically similar to bidirectional path tracing. It's basically bidirectional path tracing for volumes. So you can do sort of like God ray light shining through a piece of glass effects. Really cool with the UPVP integrator. All right, so I'm going to jump into my demo. So this is Renderman working inside of Blender. Now I'm just going to start our IPR here. So basically we have a scene set up here with a diffuse ball, a glossy, a chrome ball here. And then what I have is the Pixar, the Disney BXCF here on my teapot, and just a simple HDRI lighting the scene. So this is the Disney BXDF. I don't know if you've seen the feature upcoming in Blender 2.79, but it's basically a pretty simple PBR type shader And you have controls for doing, the base color. You can make it more metallic. And this is our sort of interactive viewport rendering using our frame buffer called image tool it. So anyways, we can go and tweak the settings on the Pixar Disney and get some really cool, get a lot of like really cool looks out of it. So, and a lot of times it's very useful to use for something like, doing a PBR workflow. So for example, here is the, let's, if I can zoom out here. Well, this is the shader network for the ground plane. So I just have a bunch of textures going into the Pixar Disney here. The diffuse color, roughness, specular, basically, and then we're doing also displacement on the ground plane to get that sort of tile look. And this is taken from polygon textures. So this is great, but like I said, we can't layer the Pixar Disney shader to sort of, if we want to do like half of it be tile and half of it be red, we can't layer those shaders on top of each other. And that's sort of one of the ideas. If you go and read the actual Disney paper on the Disney BXDF, the idea was that you layer the inputs going into the Disney shader, not the actual shader itself. So let's go look at the Pixar surface shader, because that will allow us to do some of that more complex layering. So I'm going to switch this over to doing a Pixar surface, and we'll zoom in on our Pixar surface. So Pixar surface, like I said, has a lot of different options here, and you can just turn on the stuff that you need. So right now it's just doing a diffuse. If you wanted to turn on specular, and then you got to turn up the specular color here. So basically, you're able to turn on the bits that you want. You have the options of, you have two specular lobes, you have a clear coat, iridescence fuzz, subsurface scattering. You can do glass with it. You can do a glowy type material. So a lot of like really cool, and you can use any number of these that you want. But let's just go back to diffuse here. And like I said, we can layer on top of our Pixar surface. So we see this little input material here. If I go and add a layer, and the layers are called Pixar layer, they actually have pretty much the exact same inputs. But if I go and layer on top here, and I go and look at my layer here and change the color there, it basically overrides what's below it. So that's kind of cool, but really what we want to do is mix between multiple versions of those layers, right? So let's say we want to do green and red and in a sort of checkerboard pattern. So what we do is we bring in a layer mixer. It's similar to the mix nodes, the mix shader nodes in Cycles. Now it's showing it black, but only because I don't have a second layer in here. So let's just bring a second layer. So I have my other layer here. I'm going to put that in there. And this is red. And now I want to mix between, here's my mix input. So what I'm going to do is bring in a checkerboard pattern and mix between the two with a checkerboard pattern. We'll just update that here. Okay, so now we get the green, red mixing between the two. This is a pretty simple example, but it gives you an idea of sort of layering and mixing between the multiple layers. Okay, so I'm going to stop that render there. And that looks it's a little bit overwhelming sort of to look at from the beginning, but the nice thing is that if we go and like bring in something like our BMW scene, so here's the cycles node network for the BMW scene. Now, there's actually a button here that we can go that will convert all of the cycle nodes to a Renderman node and set up the Pixar surface and all the sort of stuff here to begin with. So you can get an idea of how you would translate what you're used to seeing in Cycles into a Renderman shader node network. Okay, so that is our Pixar surface shader. And again, if you have any questions, just put them on the chat and we'll get into it later. Now I'm going to talk a little bit about lighting workflows and some new ones that are sort of new for Blender users. I'm going to take a quick break while we start our IPR render. Okay. So what I have set up here is a pretty simple scene. There's two monkey heads in it. I have a green light and a red light, and there's also a sort of background fill light here. So if we're going to look at the scene properties, we have some new UIs that we added in because some of the stuff that was in Blender wasn't doing everything we wanted to do, and I think a lot of stuff's actually like going to be added in 2.8 to Blender, so that's kind of cool to see. But the first thing we have is light groups, and basically you can make groups of lights. So let's say your red and your green here are your key lights. I made a group of lights which contain the red light and the green light, and I also made an object group here with my two monkeys. So this light lister here, it's basically something that lets me go and change stuff like really quickly. Like if I want to bump up the exposure of the fill light a little more, I could go do that very quickly here. If I want to solo a light, I could do that here. Basically giving me a lot of options for really quick for lighters. When you guys are working on your lighting, it gives you some quick options for being able to control all your lights in one place here. Another thing that we want to be able to do is link your lights to specific geometry. So let's say, for example, I want to take my fill light and only not have the fill light shine on the actual ground plane. So what I can do here is add a light link, select the two here, the fill light. The lights are on the left, the objects are on the right. Select the fill light in the plane, and then add a light link and set it to off. And then basically it turns off that background light on the ground plane. So we're only getting the green and the red light here. Again, so what we're trying to do here is have a physically based renderer, but then add artistic controls where they're needed. So that's kind of what this is doing. So the other kind of cool thing with our light groups is you can actually do light linking by group to objects, or by light group to object group, or vice versa, and lots of combinations of everything in there. Okay, so let's reset our scene here. Okay, now the other cool thing that we can do with our light group, so we have our key light group, right? And that's just our red light and our green light. Let's go and look at our AOVs. So we added some new UI to the AOV stuff. What you can do here is hit this Renderman, switch to Renderman AOVs, and we added a new sort of UI to it because the extensibility of the layer of the render layers wasn't really what we needed to do our workflows. So what we can do is we can add any number of passes we want. We have a lot of sort of preset ones. You can actually code your own passes with LPs, which are light path expressions. So let's say you wanted I want a pass which is like 3 specular bounces followed by a diffuse bounce. You could do that. But I'm just going to go add a diffuse pass here. So if I just want the diffuse of the whole scene, and then I'm actually going to add another render layer because we can do some other cool stuff, which is I'm going to take out these 2 passes. So let's say I just want the diffuse from our key lights, which are our red and our green lights, and only the diffuse that's hitting the 2 monkey heads. So for example, I'll add a diffuse pass here, and then for my light group, I can set that to be my key lights. And for my object group, I can set that to be the monkeys. And then we'll go hit render. And so what that's going to do is it's going to give me a separate pass, which is just just the key light bounces from the key lights onto the monkeys. All right, so it's going to take a second to get going because we have displacement. It has to do a pre-tessellation, just like when you're doing micro displacements in cycles. All right, so here's our main render, and I'll make this full screen for you guys. So here's our main render. This is our diffuse here. So there's diffuse of the whole scene, just the diffuse, and then here is just the key light on the monkey heads. So that's sort of an idea of the AOV flexibility we have here. All right, so that's about what I have. Is there any questions that we got?
Yeah, I've got actually one like right off the top of my head watching all of this stuff. So I know that we actually were talking about that whole like noise to like how good that image looks kind of ratio. And when I first started using Renderman, it felt like a little overwhelming. Is there any like right off the bat I should look at some of these options when I'm first starting out in Renderman? Like I'm really looking at like new users who like get in.
Yeah, absolutely great question. Okay, so in our sampling settings, similar to our cycles sampling, you can set your max samples, which is, I think it's called, what is it, anti-aliasing samples or camera samples or something in cycles. So you can set that here, and you can set your max specular bounces. The one that's really interesting and different is there's an adaptive sampler in Renderman. And you can set the variance for that adaptive sampler. So what that means is, did I get here? I'll hit render so we can see it again. What that means is in areas where it starts out with the min number of samples. So we'll do 0 samples per pixel, and then up to max samples. So here the max samples was 64, but it's going to start out with 0 samples and keep adding pixel samples to each pixel. And then if it gets to a point where it says like, hey, adding more samples to this pixel, so let's say there's like a darker area over here, and it's going to say like, hey, adding more samples to this pixel doesn't change the pixel amount by less than this pixel variance. It will stop adding pixels to that sample. So in short terms, it's adding pixels to each sample in the scene, and then towards the end, when some of the areas don't have a lot of noise in them, so for example, the black area up here isn't changing, it's going to stop adding samples there. So what you can kind of do is control the amount of noise that you want. Long story short, is you're going to control the amount of noise you want with this variance setting. So if you want to start out with a very rough, noisy image, you can do it with a higher variance setting. If you want no noise, and it'll just go to the max number of samples, you can set that to 0. So I think that would sort of answer your question of like the first thing you should be looking at as a new user.
Cool. And then another question, although I think somebody might have already answered this, but GPU acceleration in Renderman, I think that's user, right?
Yeah. So we're not accelerating the render with GPUs, and part of the reason is the same thing that was just mentioned about that scene from the High Castle was that a lot of the scenes that are being rendered won't fit in memory. So they are, and especially if you look at like the render farms that are in a lot of the studios that we sell Renderman to, they don't have GPUs on those 1U servers, and especially not GPUs that could fit that amount of memory. So right now we're not accelerating the renders with the GPU. It's always something we're looking at and investigating into. The denoise program will use your GPU if you have one, but not the render.
Okay, we got one more.
Yeah.
Is there a way to change bucket size in Pyraman? I know CPUs do a little bit better with 32 buckets, 16 in cycles. Don't know if that's a thing for Renderman.
Yeah. Yep. Down in your, I think it's in the advanced settings somewhere. Maybe we took it out. it doesn't really make a difference. There's a way you can. I think we took out we hid the option. You might be able to do it through the Python scripter, but it doesn't really make a huge difference for path tracing on CPUs. We found, so we just kind of took it out because no one was using it. It didn't really make a big difference. But there is a way you can. Long story short.
Well, cool, man. Thank you for joining us and showing this all off, and basically showing off Renderman. That it looks great. It's rendering really fast. And,
thanks for having us. And we've traditionally been more for big studios, so it's always good to get the users, the Blender users, and like guys like that who are using sort of stuff at home for them to be using Renderman too. So we're kind of like, it's fun to get to be a part of the Blender community.
Yeah, and Brian's really active on the forums and on the Renderman forums, so just hit him up.
Yes, I spend too much time online, so.
Nice. Well, thanks, dude. Thanks for coming by and doing a present.
Thanks a lot. Bye.
Yeah, man.